The length of a line segment can also be thought of as the distance between 2 points on the coordinate plane. So you can look at it as the length of the hypotenuse, or we could look at it as the way the crow flies, the distance. Modifying the Pythagorean theorem gives us distance is equal to xa minus xb squared plus ya minus yb squared, and all of that is taken the square root. Now, just a brief conversation. Remember that when we did this, we would get a horizontal distance from point A to B, suppose. So A here to B. If we're going from A to B, it doesn't matter where A and B are. You would have to get, well, to calculate the distance between A and B, you would have to get the horizontal change and the vertical change, or in other words, those sides, and then you would square the horizontal side, square the vertical side, add them together, and take the square root in order to get the distance. So really, this expression replaces the change of x, or in other words, how long that horizontal line is. This part of this equation represents, well, how tall is that triangle, or what is the length of the green lined segment? It's the exact same formula. So for any 2 points, so here's our distance formula, I'll erase it. Distance is equal to the square root of xa minus xb squared plus ya minus yb squared, all of that taken the square root. So for any 2 points, no matter where A and B are, with coordinates x and y, this is the distance formula. So we're going to talk about points A and B, and with coordinates x and y. So determine the length of the line segment with endpoints -5, 4. So -5, -4, here is A. -5, -4, there it is. 7, 1 is B. So there's 7, 1. There's B. I need to calculate what is the distance of this line. So I am going to approach this very similarly what I did last time. So there's the horizontal change. This is the vertical change. As I take a look at the horizontal change goes from -5 to +7, so that's a horizontal change of 12. Our vertical change is going to be 1, 2, 3, 4, 5. It is 5 tall, right? -4 to +1. That's a change of 5. So thankfully, I know my Pythagorean theorems and triples really well. This is the famous 5, 12, 13 triangle. So I know that my distance is 13. If you don't believe me, 5 squared is 25. 12 squared is 144. 25 plus 144 is 169. Square root of 169 is 13. All right. But instead, what I'm going to do is I'm going to use my brand new formula that I have, the distance. And the distance is equal to the square root of xa minus xb minus, or squared, plus ya minus yb. Now, I would encourage you maybe to write down these formulas somewhere so you always have them on hand. So where do these xa and xb's come from? Well, I'm going to take a look at point A. Point A has coordinates x, so I write this as xa. I write this as ya, so that when I look at it, the x-coordinate of A, the y-coordinate of A. And these little letters here are called subscripts. Very useful for keeping track of things. My point B has coordinates xb, yb. So if you want, you can just simply write xa, xb, ya, YB just to help you out and we get started. What I notice is that my XA is -5. My XA, -5. Now, my Y, since I'm talking about A, my YA is going to be -4. Let's move on to XB. So XB, that's my X coordinate of B, which is 7. Now my YB is the Y coordinate of point B, which is 1. So just using the distance formula, I get my distance is equal to, I'm just going to plug it in, -5 minus 7, and I'm going to square that, plus -4 minus 1. I'm going to square that. And what I get is -12 squared plus -5 squared, all taken the square root of. So very simply now, I have to do order of operations, so I need to square it first. So -12 squared is 144. When you square a negative, it becomes a positive. Plus -5 squared is 25. And what I get is that this is the square root of 169. Notice what I was talking about earlier. So therefore, the distance is (13). The square root of 169 is exactly 13. Well, that worked out well. Let's move on. I'm only going to do one of these examples. Why not? Let us do example number 5. I'm going to call this point A and this point B. Does it matter which one? Definitely not, as long as we stay consistent. I'm going to call this XA, YA, XB, YB. I have my formula for distance, so, and by the way, you have it too on that separate piece of paper that I've asked you to write it on. The distance is equal to the square root of XA minus XB squared plus YA minus YB and squaring that. Now over here, I may want to write what is XA. XA is equal to -15. YA is going to be equal to 12. XB is going to be equal to -3. YB is going to be equal to -9. So you notice I'm not even going to deal with the Cartesian plane. I have this beautiful formula that solves a lot of problems. It should result, or it should match up with my Cartesian plane answer. So therefore, the distance is equal to, I'm just going to plug in my values. XA was -15 minus XB, -3. I'm going to square that. Plus, you notice how I write my brackets first. YA, which was 12, minus -9. Now, I should be very careful. Here we are. -15, or -15 minus -3. Remember that subtracting a negative is like adding a positive. So what I get is -12 plus 12 minus 9 . So subtracting a negative, so what I get is, this is 21. That's a pretty big Distance is going to be fairly far here. So the distance is going to be equal to the negative 12 squared, which is positive 144, plus 21 squared, I believe that is 441. Now let me just check. Indeed. So if I add these two together, the distance is equal to the square root of 585. Now, I'm not so cruel to do this any other way than a calculator, so the distance is equal to the square root of 585, which ends up being 24.1867. We're going to keep 3 decimal places, so we're going to round. So this is going to be equal to 24.187. All right, I think we're ready for some practice. Let's get at it.